right. Good evening, everybody. Let's move on to the second part of the meetup. You know, Dennis was asking whether I've been to the meetups, to this particular meetup before, and I have a couple of years ago, and I remember thinking, wow, this is such a cool meetup. People are talking about infrastructure and automation. This is exactly my domain. Exactly. Happy to be the witness. And I was thinking, I would love to be part of this community. And would you look at that? My name is Natalie Godec, and for the next half an hour, we're going to be talking about Terraform. And one of the subjects that comes up again and again in discussions about design and configuration as code, and how do you manage your infrastructure, and what's your architecture. And it's, if you can, it doesn't necessarily mean that you should. I'm a cloud/platform/DevOps/systems engineer, whatever the next title for this role is. I work for Babylon, a London-based health tech scale-up. I'm mostly interested in infrastructure, in data platforms, and in security. I'm also a photographer, and you can find my socials at UVSuite. Babylon is a digital healthcare company. We're on a mission to bring accessible and affordable health service into the hands of every single person on Earth. This means digital, this means cloud native, this means AI powered, this means a lot of data. And I'm a staff cloud engineer now in the data platforms team. And one of the core ideas in my role is automation, which is shortly followed by abstraction. And we've come a really long way. We started with physical servers that had to be ordered, and we had to wait for a long time for them to be provisioned. Then came virtualization, and we were able to abstract away the fact that there are physical servers out there. Came a configuration as code, and we were able to abstract away the fact that there are VMs and automate their provisioning. Then we had containerization. Who needs to think about VMs again? And now we have cloud technologies, and we don't even know that there is a VM or a physical server somewhere underneath our Lambda Cloud Run and whatnot. And we have infrastructure as code. We write Terraform to automate and abstract away the provisioning of cloud resources. And we write pipelines to deploy our Terraform and abstract away the fact that there is code. And these layers are coming in and in and in, and we come up with more and more automation and more abstraction. But where do we draw the line? Is it here? This is a perfectly valid piece of Terraform. It takes in an input of maps, or like a list, and transforms it into a different kind of map. I particularly like this part. I call it black magic. It gives me reassurance when someone comes to me and asks, hey, Natalie, how does this work? And I can answer, I have no idea, because the code itself suggests that it also has no idea. Or is this where you draw the line? Imagine trying to debug something in a state of 2,000 resources. What if someone forgot to enable encryption on your database, on their database in those 2,000 resources, or left an IAM role that is giving up too much access? Terraform is first and foremost a configuration language. What you do is you describe the desired end state of your infrastructure. It is fundamentally different from normal programming languages where you instruct the machine to do something. With configuration languages, we don't say, hey, build me a VM with 20 gig of memory. We say, hey, I would like a VM with 20 gig of memory, and the system figures out what to do. Now, with advancements of Terraform and with advancements of modules and more transformations built in, and possibility of adding modules and adding ifs and conditionals and all of those things that come from the world of more kind of procedural languages, it becomes, on one hand, easier to write your Terraform. If you've ever had to write Terraform 0.11 and then moved to 0.12, 13, 1.0, whatever the version is now, you will have noticed that your code has become a lot simpler, and it's a lot nicer to write, it's a lot more pleasant to write. But there are also risks coming with all of those complexities. You can fall into trying to do something with Terraform that is not quite a configuration language. With those risks come dependency loops. You might introduce them, and it's really difficult to find out where exactly in that 16 lines of code is your exact dependency loop and where to break it. You can have state drifts, and anybody who has ever dealt with state drifts hates it. I haven't. And I'm pretty proud of that. I'm pretty happy with my life and my Terraform journey so far. My personal pet peeve is inconsistency. I really like all of my resources to be consistent across environments, across locations, across all of the deployments. If my VPC is called dev UK, but dev UK EKS, I don't know, and then prod UK Kubernetes, I will not like that. I want them to be called the same way across environments and have consistency in them. Of course, you will introduce security holes because with complexity comes difficulty to manage your infrastructure and manage your security standards and security guardrails. And also, if the stuff that you've written is too difficult to use, people will come and see it and look at it and think, nah, and go away and write something of their own. And we call it off-the-road implementations. I work for platform teams, and I have worked for platform teams for a while, and we try to set the standard for the company. What is our preferred way of deploying a particular piece of infra? If people go away and start implementing their own, they will not necessarily follow that standard. And you end up with inconsistency and security loops, security holes, and all of that. But fear not. There are lessons that people have learned, and the industry has been converging on some golden standards. Before that, let's look back at what you can fall if you haven't learned from the industry and the golden standards. These are really easy to fall into, particularly if you are only starting your journey with Terraform or with configuration or infra management. You might end up having a module for some infrastructure and then decide, oh, I'm going to put all of my resources in it. And then you have a kitchen sink and it's really difficult to manage. Or you might say, okay, no, my module manages databases. And then you have another use case, oh, I'm going to add that use case. And then you have another version of it, oh, I'm going to add that version and the conditional in that module. And you end up trying to abstract every use case, and complexity grows, and the usability of your module becomes less easy to use. And if you add transformations and conditions everywhere, trying to abstract those use cases and trying to add every single resource in the same module, it all becomes one giant mess and not really a module anymore. Another thing is procedural flows. Again, Terraform is a configuration language. You want to describe the end state of the infra, but you can introduce procedural flows and conditions and dependencies and whatnot. One thing that people who work with, like infra as code and all of those languages, know that it's not good to do, but everybody has it in their code, our local execs. Sometimes it's way too easy to just add a command that will run. Okay, if you have to do it, fine, but it's not nice to introduce those in your Terraform. Local execs don't behave like Terraform resources. They don't provision infrastructure. They're not idempotent. And they're really messy to debug if something goes wrong. And there are also pieces of infrastructure that don't lend themselves really well into being in Terraform. One example is VPC peering in AWS. You need to initiate it in one account, then go to a different account and confirm, wait for AWS to do its thing, and then finalize the procedure. Yes, there are Terraform resources for that. Does it lend itself nicely into a module and in a single procedure? Probably not. Another example is Kubernetes on cloud, so your EKS, GKE, AKS. It's massive and there are many resources to manage, and you might have to provision something and wait for that to finalize, to then initiate a different state, and then pick up the outputs of the first one, run some Ansible on your nodes to harden them, copy some secrets somewhere. Again, yes, there are modules for that, there are resources for that, and people have done it, but it's one of those really difficult and challenging tasks where you might find yourself stepping a little bit away from Terraform for managing the entire deployment, or maybe break it up in separate places, in separate parts. And of course, all-in-one states, that 2,000 resources state that we saw at the beginning is not a nice pattern. You might think that it's nice to say, okay, I'm going to put all of my databases in the same state, and it's okay if you have 4, but what if you have 400? And someone forgets to enable encryption at rest. From a security perspective, one thing that I've seen is trying to put all of the IAM roles and IAM policies in the same place. And it's very nice from the point of view of the security team, because they can manage everything in the same place. They can have ownership, they can have like pull request review requirements. But it's not nice from the user end point of view, because how do you, like, if I want to provision a resource, but I need to make a change to the central place with all of the IAM policies, how will that work? Why do I have to do changes in two different places? You also need to think about usability and what the end team is going to think of what you have written. And of course, if you have to do targeted deployments, it's when you do Terraform apply -- target, choosing one particular resource out of the entire state, please don't. If you're just testing something locally and you want to run something really quickly locally on your machine, that's fine. But if you know that your deployment will break unless you do target, you have to refactor your Terraform. It's not working, it's not gonna work. You know that you need to do a target. You will leave or go on vacation. Someone else will come in and have to deal with that. And they will have to rewrite it. So maybe think a little bit further away and understand that, okay, something is wrong, I need to fix this thing. Now, how do you approach Terraform to make it nicer, to avoid all of those risks and misconfigurations? One suggestion is to find your single point of deployment. What is a single point of deployment? It can be all the infrastructure that is needed for a particular service or microservice. Let's say you have something and it needs like databases, IAM roles, whatnot. That might be a grouping for a single point of deployment. Or it might be a group of resources that a particular team uses. It might be useful if you know that that team is going to be using the same set of resources again and again in their work. Just group them in a single point of deployment and have that module, that service, managed by that team. They will have the ownership and the power to manage their resources, while you have the assurance that what they're using is compliant to all of your standards, regulations, and all of that. Another point of deployment might be a complex piece of infrastructure, something that requires so many additional resources that it wouldn't be able to function correctly without. And sometimes it doesn't make sense to integrate those complex pieces of infrastructure into your other modules, into your other points of deployment, but makes sense to separate them. Let's look at some examples of these. All of your infrastructure needed for a particular service. Let's say you have a microservice managing client profiles. It might need an RDS instance and a parameter group. We're looking at AWS resources for this example. It might need a security group and some rules to enable network access. CloudWatch logs and alarms for monitoring and alarming when something goes wrong. SNS topic for the alarms for the delivery, IAM roles and policies for access, KMS key for encryption. This group of resources serves the microservice that is dealing with client profiles. The client profiles team will be able to manage these resources. Or let's take an example of an AI team that is dealing with some data. You will know that they will do the same thing, the same workflow again and again. They will need to work in Google Cloud and take advantage of all of those awesome AI tools that were announced yesterday at Cloud Next. So you will say, okay, they need a GCP project, they need network and DNS if they need that, Cloud Armor rules to protect the whole shebang, BigQuery datasets because they work with data, storage buckets, again, IAM roles for access, and maybe they will want to use some serverless tools like Cloud Run and Vertex AI for their ML workflows and for their AI research. You group that up, put it into a module, give it to the AI team, and they can manage it. And for the complex infrastructure example, let's take OpenSearch. AWS has managed Elasticsearch, and it's all nice and fine. Okay, managed Elasticsearch, just deploy a cluster and you're free to go. Not quite. You will deploy the cluster, but you also need security groups, security group rules, logs, alarms, SNS topics, IAM roles, IAM policies, KMS keys, and also OpenSearch needs to be configured within OpenSearch, and that cannot be managed with Terraform, but you want to give your clients, your client teams or whatever, a fully functional OpenSearch cluster, so you will want to put the configurations in place But how do you do it? Local exec is not nice. A pattern for that is a Lambda. You have the configuration in a file. You either git ops it or put it into S3, and the Lambda will pick it up and then configure the OpenSearch cluster. Your OpenSearch cluster will not be functional without all of these resources. So this might be your single point of deployment. How do you identify them? They have a couple of characteristics. You might have figured them out from the examples. These resources change together and they belong together. They live together and evolve together. They have no internal conflicts or dependency issues. They can be tested and deployed together in new releases, in new versions. And they're independent from the rest of the infrastructure. Now, obviously, all of the criteria are a little bit variable, and you might find that OpenSearch needs a network, but you will probably have provisioned network somewhere else. That is not necessarily a dependency on some other piece of infrastructure. It will already be there, and you can pull down the data with the data resource. Once you have done that, you have figured out, okay, this will be my standard. You will want to define your design patterns, your guidelines, and your guardrails. Why? To enable your end-user teams to self-serve and be self-sufficient. A, because your team doesn't scale infinitely, and B, just because it gives them the power to manage their own infra. What are those? Your design patterns will be really well-documented standards of how you do infra in your company. Again, your preferences, your modules, how to use those modules, they will be consistent. You will try to make your Terraform modules consistent across the board in terms of their structure, right? Like what is the input gonna look like? How are we gonna version them? What are we gonna deploy in different environments? Those will be your design patterns. Your guidelines will be your security standards, your compliance standards, all of those things that you want to tell people to do or not to do, like enable encryption at rest in databases. Once you have told them what to do, you will want to enforce them with guardrails. There are tools like Checkov and Terraform Compliance, or cloud tools like GCP organization policies, AWS config, Azure policy. You can enforce those security and compliance rules on the organization level, and nobody will be able to do something that they're not supposed to do. And the good thing is that you can integrate all of that into your CI/CD and make everyone's life really easy. Level 1, you integrate Terraform format check and Terraform validation. Really easy. These are just Terraform commands, literally. In this screenshot, you can see a bot that posts a comment on GitHub pull request for a change in Terraform. Okay, everything passed. Level up, introduce Checkov. This QR code will take you to the Checkov website. Scan it if you want to. Checkov has a set of community standards and checks against your Terraform code. It will scan your configuration and your modules before you have deployed something, and check them for these standard practices that are supposed to be there or not be there, like your security standards, your kind of style, maybe design standards. You can also write your own policies for whatever is necessary within your company. Checkov is really easy to use. You can, literally, it's a GitHub action or whatever, check it out. It's really, really easy to install and use, and it's just there with the community policies. Next one is Terraform Compliance. This is also a QR code that will take you to Terraform Compliance website. Terraform Compliance is like OPA, but for Terraform code, and you write your own policies. You can also use the standard ones provided by the community, but basically you describe the behavioral practices of what people will want to do with the infra. And they allow you to be really flexible around your security posture and your compliance posture. And again, your code will be checked before it's deployed, so nobody can merge something that they're not supposed to be deploying. And again, you integrate it with your CI/CD, and it's there. You don't have to worry constantly about what people have written in their Terraform. What will they deploy? Which security holes they're going to open? The Terraform will be checked, and they will not be able to merge the code without those checks passing. And the tool that has blown my mind, that you can also integrate into your CI/CD, InfraCost. This is also a QR code that takes you to InfraCost. It calculates the cost of your resources. Come on. You write some Terraform, you open a pull request, and it tells you how much it's going to cost. those AI people for whom you have provisioned the GCP project and they have done a TPU or 24 GPU instance, they're gonna see how much it's gonna cost, and maybe they will rethink the number of GPUs they want to put into their instance. In this example, provisioning an MSK cluster managed Kafka on AWS is gonna cost a little over $1,000 a month. But also we did a cost-cutting exercise a couple of months ago, and it was very satisfying to see these little comments on the pull requests when you're like, you're cutting $6 grand a year, you're cutting $900 a week with just a couple of resources.
Can you fail if it's too high? It's like if it's $6,000 and you've only got budget for 5.
Right. That's an interesting point. Probably yes, with some clever CI/CD, because this is written into your CI/CD.
I'm a software engineer. I'll just take the pull request too.
Yeah, that's where AWS config and GCP org policies and budgeting come in place, where you introduce budgets like organization-wise, because developers are clever. Yes. And once you've done all of that, you've defined your standards, your design patterns, your guardrails, your end users will be really happy. This was a particularly pleasant and pleasing message from one of our team members. After we moved all of our Google Cloud Terraform onto like a new design pattern with a better version of Terraform and better standards, and like everything was consistent, and we documented everything. And it suddenly became so easy to use. And so we received a little round of applause, and it was very pleasant. So as a conclusion, if you want to take something out of it, when you are writing Terraform, or anything really, remember the KISS principle. If you don't know what it is, Google it. It's my favorite engineering principle. Always ask why. Why are you writing those transformations? Why is there black magic? Why are there locals files that are 70 lines long? Why are you doing a particular thing? What is the end goal? And is it going to be useful, easy to use, future-proof, and maintainable? And in the words of Anton Babenko, who is a Terraform community hero, guru, AWS guru, and overall really, really active person who's developing loads in the space of Terraform, think about understandability. Whatever you're writing, you will have to make sure that it can be read and understood by other people, because other people will have to maintain what you've written. So think about them. Be nice to them. Babylon is hiring, so if you want to come and work for us, please do. And thank you very much for your attention.